Hi guys, welcome back to the Electrical Training Center. Today we're gonna go over some different types of calculations. The first one I'm going to explain is how to actually understand what a series and parallel circuit is. And once you understand that, we could combine them and do a series parallel combination circuit. And that's what we're trying to accomplish. So let's go back to basic Kirchhoff's law and everybody, so we understand each one. If we want to do a Kirchhoff's law in series, Kirchhoff's law. I spelled Kirchhoff's law wrong, but it doesn't matter. Kirchhoff's law in a series circuit, what you need to know, the total current, IT, is equal to I1, which is equal to I2, which is equal to I3. An example would be, if I1 is 2 amps right here, then this has to be 2 amps. This has to be 2 amps. And IT has to be 2 amps. Okay, so that has to be equal in a series circuit. The voltage, ET, is equal to E1 plus E2 plus E3. You just add them up like a battery. Okay, if you have a 3 volt and a 3 volt battery, that'd be 6 volts. Okay, if you have 3 volt batteries, it's 9 volts. It's a series circuit. And then in the ohms, which is resistance, RT is equal to R1 plus R2 plus R3. Okay? So that's it. And power, just FYI, is PT equals P1 plus P2 plus P3. So that's a series circuit. Now a parallel circuit is a little different. And let me just explain. ET, which is your voltage, ET, which is voltage, is equal to E1, which is equal to E2, which is equal to 3E3. Okay? And I'm just going to draw a picture so you understand this. Let's say I have a panel. And I have a breaker here, 15 amp. And I got a light here. 1 light. 2 lights, 3 lights. Okay? And if you look, here's my neutral bar. And if you look, it's in parallel. So just think about a light. If I have 3 lights in a regular circuit at a house, all the voltage is the same, right? Okay? And this is what it looks like when we do it scientifically, or how they teach in school. They'll do this. They'll either draw like this, or they'll put a generator, and they'll do this. Okay, then they'll draw a squiggly line like this, like that, and they show resistance. There's a resistor to a light. And what I show in class is I just put a light bulb. 1, 2, 3. Same thing. This, and this are the same thing. So ET will always be the same. Think of your reciprocals. Okay, we wire them also in parallel. So I just want to let you know that, which is important. What also you need to know, IT, and I'll leave this up, IT is additive. IT is, the total current is I1 plus I2 plus I3. So an example is, okay, here's my generator, whatever you want to have. If this is 2 amps, this is 2 amps, and 2 amps, the total IT will be 6 amps, right? Very simple. And same thing with power. Power, PT, is equal to P1 plus P2 plus P3. Hey, here's a circuit again, whatever you want to make it, and say this is 10 watts or 10 volt amps. 10 volt amps or watts, it doesn't matter. Okay, 10 plus 10 is 30. So PT will equal 30 volt amps or 30 watts, depending how we do the calculation. Okay, so like a light bulb, if you have a 100 watt, if this was 100 watts and this is 100 and this is 100, that'd be 300 watts. So the answer would be, PT would be 300 watts. What gets crazy is the resistance. And The problem with resistance, and this is the formula that we always use, RT equals 1 over R1 plus 1 over R2 plus 1 over R3, which makes sense, but if you're not a good math teacher, or not even a teacher, but if you don't understand math that good, we always have a problem. Most of the guys in the trades are visual. So I'm going to show you an easy way how to do this. Very simple. Instead of doing it this way, we're going to do what's called the matrix, okay, to find R. And the matrix is very simple. Let's say we have R1 is equal to 10 ohms, R2 is equal to 20 ohms, and R3 is equal to 60 ohms. Okay? What we're going to do is, we're going to first, and just it's very important that you understand this. If I have a toaster oven, and here's my resistance, then I got a plug right here. Here's my plug. If this is 10 ohms, is this ever going to change? No. I could put 120 volts on it. I could put 240 volts. I could put 277 volts. I could put 480 volts on it. It'll always be 10 ohms. So RT, this number right here, this is T, this is resistance 1, resistance 2, resistance 3. This is EIR, voltage, current, and resistance. RT will always be 10 ohms based on whatever the voltage is. So remember, in a parallel circuit, what stays the same? Voltage. So watch how simple this is. This is how crazy this is. They should be teaching this in like 3rd or 4th grade, okay? Because it really is very simple. Let's say we use a voltage of, now let's make it up a number, 60 volts. And in parallel, look what it is. Parallel, it's equal to E1, equal to E3. So we just put 60 volts here. Okay? 60 volts. Okay? All the way across. And we're given, this is 10 ohms, this is 20 ohms, and this is 60 ohms. Now we could do basic Ohm's law. We want to find I, and in I, it's additive. But we got it, based on the 60 volts, we're going to find RT. And you can use any voltage you want. I'm going to prove it to you in a second. 60 volts. So you go 60 divided by 60 is 1, because this is the formula, E equals I times R. This means equals. There's a formula, and whatever you want to look for, if you want to look for I, you cover I. Say, hello, I, and you take your hand, say, hello, hand, and you cover I, and it's E divided by R. If you want to find R, it's E divided by I. And if you want to find E, okay, it's I times R. Very simple. So here we want to find R for each one. So here you go like this, and here's the picture, again, what we're looking at. So you can see exactly what we're looking at. R1, 10 ohms. R2 is equal to 20 ohms. And R3 is equal to 60 ohms. Okay, that's the picture so you can see. And right now we're using E equals 60 volts. That's what we're using in this one. And watch what happens when I double the voltage. But first let's do this. We know this is 1. How do I get it? E equals I times R. We're going to cover I, and it's E divided by R. E divided by R, I equals E divided by R. So 60 divided by 60 equals 1. Okay, so there's 1. Next one, we got 60, number 2. This is number 2, resistor number 2. 60 divided by 20 goes 3 times. So this is 3, and 60 divided is 6. We add it up, that comes out to 10, right? Based on this voltage, you're going to get this amperage, okay, which is 10 amps. 60 divided by 10, if we do Ohm's law again, we want to find R, we cover it. So R equals, cover this, E divided by I, which equals 60 divided by 10, which equals 6 ohms. Okay? So the answer is 6 ohms here. And it'll always be 6 ohms based on these fixed resistors. And I just want to prove it to you. Watch this. Let's say Let's make another, this is called the matrix. Just watch. 1, 2, 3. Total. 1, 2, 3. E, I, R. Voltage, current, resistance. We're going to use the same numbers. 10 ohms, 20 ohms, and 60 ohms. Let's double the voltage. Here we got 60. Remember, the parallel circuit, voltage stays the same. So there's 120 volts, 120, 120, 120, right? And now this is 120 volts. Okay? Watch what happens. 60 divided by this is 2, this is 6, and this is 12. Look at the comparison here. I doubled the voltage. I went from 60 to 120. Look what happened to the current. It doubled, right? This doubled from 3 to 6, and this doubled. So what do you think current's going to be? It's going to be double, right? 12 plus 6 plus 2 is what? 20. And 120 divided by this is still 6 ohms. You can use any voltage. You want to make it 480. You'll always have 6 ohms based on these resistors. Okay? It's fixed. So this is a very powerful way to do it. It's a better way. You could see what's going on in the circuit and everything. So let's do the actual problem now, and we're going to combine the both circuits using this method. Okay? Any questions? Probably not, because you can't hear me. But if you ever want, you could go to our websites where you could see more videos and everything. So let me get rid of this. Get rid of this. Get rid of this, and I'm going to keep these formulas up there so you have it. Okay? So here's the problem. They want to know what the voltage drop is across a 20 ohm resistor. And all 12 ohms loads are 2 amps. So I'm going to draw a picture of what we're trying to accomplish here. We got a light or resistor, it's irrelevant. We got a light here, parallel. Parallel. And this is the circuit. So what we want to do, we want to take this, and I call it squish. We want to squish this to one resistor, one light. And right now this is parallel. Okay, this is called the parallel, and this is series. So this is actually called a combination series. So we're going to call this, what it's going to look like afterwards, it's going to look like this. We're going to call this A, RA, okay? Because when we take this is going to be an A, resistance A, not total. So we're going to plug in numbers, okay? This is 12 ohms. This is R1, which is 20 ohms. R2, which is 12 ohms, R3, which is 12 ohms, and R4, which is 12 ohms. Okay, that's given. And also, these are all 2 amps right here. All the 12s, I4 is 2 amps, I3 is 2 amps, and I2 is 2 amps. Okay? And what else is given here? And that's about it. And we want to know what the voltage drop across this. We want to know what the voltage drop is across resistors once. So what we're going to do is we're going to take this and we're going to make this smaller. Okay? We're going to actually make this smaller. So we're going to make the matrix. Like I showed you before, you got 1, 2, 3, 4. We're going to call this A because this is what we want to get. We want to make that A, okay? We want E, I, R. What's given is, this is given at 12 ohms, 12, and 12 ohms, correct? This is resistor 2, resistor 3, resistor 4, right? Resistor 2, resistor 3, and resistor 4. Okay? And what else is given? All the 12 are 2 amps. 2, 2, 2. We do basic Ohm's law. This is 24. 24, 24. So this is a parallel circuit, so this has to be 24 also, right? Okay, this is in a parallel circuit, the current is additive. It's 2 plus 2 plus 2 is what? 6. And in a parallel circuit, you just multiply this, 6 divided by this. So RA is going to be 4 ohms. Does everybody see that? 4 ohms. You don't add this, you do Ohm's law here. 6 divided by 24 is 4 ohms. So that's given here. So right in here, we know that EA is equal to 24 volts. We know IA is equal to 6 amps. And we know that RA is equal to 4 ohms. We also know that this is 20 ohms, R1. So now we could do the matrix for this. Okay? We just draw a picture. Here's total. This is A. This is 1, and this is A. Okay? And we just plug in the numbers, E, I, R. Okay? So A, we got 24, we got 6, and we got 4. Okay, 6 amps, and this is 4 ohms. And in R1, we know R1, this is 20 ohms. So let's look at a series circuit. Series circuit, what stays the same? Current. So this has to be 6, and this has to be 6. Has to be! You can't change it. This is a law. You don't go through a stop sign, right? It's a law. These are laws. Kirchhoff's law. We could figure this out. 6 times 20 is 120 volts. And if I add this up, this is 144 volts. And this is additive, right? 20 plus 4 is 24 volts. And you could do this too. You could do 24 times 6 is 144. So the question for this one, we want to know the voltage drop, or the voltage in the voltage in this one, in resistor number 1. So if you look, the answer has to be 120 volts. And that would be the answer for this. Thank you, and just subscribe to us on the bottom of our website, and you'll see that. Thank you, and have a good day.